Thank you all for coming to our first 5 for 5 of the season. My name is Courtney Cosden. I'm with University of Idaho Extension and USDA NRCS as a partner position. My title is a soil health instructor. Lucille and I with the NRCS run these 5 for 5s, and we do field days in the summertime, and just general outreach and education. Um, Lucille Rollins is on the call, but she's having a little bit of connectivity issues. So I'm going to introduce her real quick or just tell you who she is. So Lucille Rollins is with the USDA NRCS as a soil health specialist, and we work together a lot and we put a lot of events like this on. So Lucille's on, and I'm sure she'll ask some questions of our presenters if she gets some connectivity back. So yeah, thanks for bearing with us this morning with the delay in the timing. I'm glad that all of our speakers were able to come on, and it sounds like Moscow is still mostly without power, but the college or the university has power, so they were able to come on, come to work and come and hang out with us and talk about soil health. I want to mention one more thing before we get started. We have our big, hold on, I'm still admitting people. We have our big soil health event coming up January 8th. It's the Magic Valley Soil Health Forum, which is primarily producer-led breakout sessions. We'll have 8 different unique breakout sessions with topics like nutrient density, reducing tillage, uh, what else? Livestock integration. There's a lot of really great topics, and most of them are led by Idaho producers. So it's January 8th. If you're interested in that event, registration is up until, or you need to RSVP by January 2nd. And it's an all-day event, really just all about conversations between growers and yeah, getting the conversation going about soil health. So if you're interested in that, just shoot me an email, or if you want to put a message in the chat, I can send over some more information about that as well in the chat. These are recorded. This will live on our University of Idaho Soil Health YouTube page, as well as all of the previous 5 for 5s. We do 3 of these every winter season. So all of the past ones are on our YouTube as well, so you can check that out, and I'll put the link in the chat. Okay, I think that was all of the preliminary things that I wanted to mention. So the way these 5 for 5s work, if you haven't joined us before, normally each producer or presenter will have 5 minutes to present 5 slides or less on a certain soil health topic. Our theme today is University of Idaho Soil and Water Systems Research Faculty. Our Soil and Water Systems faculty going to be presenting on their research that relates to soil health and regenerative ag. So we have Dr. Erin Brooks with us, Dr. Daniel Strawn, and Dr. Michael Strickland. Since we only have 3 presenters today, I'm going to give them some more time, so they'll probably talk for 10 to 12 minutes. And in Dan's case, he might keep going, like he mentioned earlier if you were on the beginning of the call. But yeah, it'll be a little bit loose today, and if you need to drop off at noon for lunch, that's totally understandable. But thanks for bearing with us with the delay. So I think with that, that's all I needed to say, and we can get going with our presentations. The order is going to be Erin, and then Dan, and then Mike. So Erin, if you are all ready, you can. Did you have slides, Erin? Do you want to pull up slides?
Yes.
Oh, wait, hold on. Let me make sure that you can do that.
Yeah. So yeah, thanks, Courtney, for hosting this and this exchange of information that you guys have. And so my background, I'm an agricultural engineer. I really focused on a lot of my career, and still am to some extent, is the hydrology and water quality. But if you describe me, what I do is look at spatial patterns within landscapes, and which makes me really amenable to precision agriculture and targeting. And so a lot of the things I'm going to be talking about today are tools that I've been using that I think are really useful tools for any producer who's trying to adopt some new practices. And so that was, let me see if I can open this up. I don't know. Are you seeing a PowerPoint? Are you seeing like a remote sensing image?
I'm seeing the remote sensing.
Okay, I'm moving this over.
Perfect. That looks, oh, except it's in presenter view, but
Yeah.
oh, there you go. Perfect.
Yeah, this is the title I just put together is how do you to know whether your soil health practices are working. With regenerative ag and a lot of innovative growers out there, you can do a bunch of stuff, right? People are trying things all the time, from compost tea to bioamendments to the latest, greatest thing that was going on. And like, well, all right, I'll just throw it out there and see how it works. And really, it's, some things in terms of practices, you can actually see immediate response. Some would take a long time. This is what you're going to, some different projects, and depending on how much time I want to give Dan, I can go on for a long time talking about different projects where we've applied tools to help track changes, on-farm changes, and really focus a lot on satellite imagery. So let me get this thing out of my way. Really the question you want to ask if you're a producer, am my practice making a difference at all? They're trying new practices, but seldom, you go to conferences a lot of times, especially with regenerative ag, and you get some testimonials. You get some people putting some plants and some roots on the back of a tailgate and kind of saying, yeah, that looks a little better. I have some indications that maybe it's better, but there's not a lot of really evidence going back in time, or are you sure it wasn't just the year? And so, sometimes in terms of why is there a lot of evidence? It takes time. And the soil is particularly organic matter or any organic feature of a soil. It takes a lot of time to actually build up that organic matter to actually see a difference. And so you're looking at 5 to 10 years before you even measure a difference, even if you take soil samples, because it's the precision of your measurement or the spatial variability within your field to even make a measurement. So soil sampling sometimes is difficult, particularly if you're looking at organic measurements and weather extremes. I mean, we just got done, I'll show you an example of a cover crop trial that we were doing, and every year we had one of the worst years in droughts in history, and then we followed it up with one of the best years. And so you're looking at different weather years. It's like, well, maybe I had heat stress the first year. Well, maybe the next year I had excess water. And so you're like trying to figure out what's going on, and so it's hard to distinguish what's actually happening. So what can we do really to quantify improvements? One of the things I'm just pushing here and with the tools we have is, try to make a plan. Make a plan to document that change. And that means maybe kind of starting to think like a scientist to some extent, but you don't have to have a degree and set up multiple small replicated trials, because if you're a producer, then you just don't have time for that. But there's things you can do and tools you can use to actually track whether things are making a difference, as long as you set up the experiment right. And so oftentimes you think of an experiment, you have to have a control and a treatment, and sometimes you have replications, right? Those are what you kind of think about. And so what I'm pushing in this little talk is take advantage of satellite imagery. And satellite imagery, it goes back a long ways. It's really, now some of the satellite imagery is really frequent. Probably most of the people know about Landsat and NDVI going back. I mean, that goes back to the 1980s. And those are like once every 16 days for one satellite. And sometimes we have 2 satellites up there, so you get 8-day frequency replication. And those are 30-meter grids. So as long as you're getting a strip that's 100 feet wide or a little bit more, then you could actually see, you can actually pick up a treatment, an on-farm trial on a specific farm. And since 2017, we've had the Sentinel imagery, Sentinel-2. Landsat does the NDVI and the surface temperature. Sentinel-2 gives NDVI, and now they also have this red edge, which is really sensitive to nitrogen and chlorophyll in your plants. And so they have both those, and those are like every 5 to 10 days. So now we're getting pretty frequent imagery on their 10-meter grids. Now your trials really, and maybe it only has to be 60 feet wide. So you get 60 feet wide strips you put in your middle of your field and try something. Put Dan Strawn's biochar on 60-foot strip in your field and take it up and over a top of a hill or across your poor ground or your good ground, and then track it. And what I'm going to show you is actually how you can do a tool to actually track within a year, but also if I get time for it, actually we can go back in time and see if as the persistent patterns within your field have changed since you've adopted a practice. Maybe you went over to no-till. Maybe you went to some sort of organic amendment some 3 or 4 years ago. Well, we can go back and look at the relative production, relative indication of crop productivity using satellite imagery and actually see if it made a change and a difference. And the only thing that's really changed, the satellites has always been available. It's just been, gosh, how do you get access to it? You got to be like a GIS wizard or remote sensing wizard to actually use it. But now I'm going to say you don't really have to do that. So a couple of products, and if you're in southern Idaho and you're in irrigated country, really you have a lot of extra advantage. And you probably have already heard of the metric model, but this is a tool to actually track of the consumptive water use from your plant. And so you can actually go into any field, and even specifically parts of the field, and look at consumptive of water use. How much water did my crop use within this field? And you can see spatial patterns within your field. You can zoom in. You can do this within 5 minutes, and you can go back in time and click on a specific field. And in this case, center pivot here. And here you can actually look at monthly evapotranspiration. You can actually get daily if you look at the specific grids. And so you can compare one field to the next. All right, I did something for this field. How did that change my actually crop productivity in terms of water use? So that's one tool that is available. And if you guys haven't checked it out yet, I mean, I really encourage you to look at that and really look at back in time. You can look at drought years. You don't have to be an irrigated user to use this. You can put in dryland. We use this up on the Palouse as well. So that's one tool. The other one I just wanted to show, and I think this is a really useful one for on-farm trials, is Climate Engine. And this thing is, really expanded. And the ease of use is really, it's really easier and easier to use now. And I think even producers can use it. And if I can get to a demo, and this is how we use it. Here's our cover crop termination trial, where we're, instead of having a fallow field, and this is in kind of the Palouse area, let's compare a fallow field to a cover crop we planted, and this is a dry area, 15-inch precip zone, and we're going to follow fallow with winter wheat, and we don't want the winter wheat to be impacted by the amount of water we consume, and so we terminated these parts of our cover crop on different dates, and so we have a different termination dates. We did one in 1st of June, one in the end of June, one in the middle of July. And we just want to see how well the termination worked. And so this Climate Engine tool, it's just kind of like Google Maps. You can drop in, and here's just NDVI this is the average NDVI from June 15th to June 30th in 2023 for a specific field. And you can zoom in on this. You can actually see a red is really dry, bare soil. The green, the more green it is, the more lush it is. And you can see there's my trial. Boom, there it is. The red is all fallow. The strips were in here. You can actually see the northern strip, and this one has already been terminated by June 1st, because that's what Risk Management Agency tells you have to terminate it to keep your crop insurance. And then you can come in and get different time periods. This is July 1st to July 15th of the winter wheat year. We can actually see the following winter year and how is it impacting my crop productivity. And so you can actually make maps. But the really cool thing is what I think is you can actually make maps, but then you can drop a pins. So I'm just going to drop a pin, or I can put a polygon in. And here's blue is the outside the plot. Green is the first termination date. Orange is the second terminate date. Purple is the third. Now, these are big enough so I can see them from the satellite imagery. And then what the tool does is they just pull up this NDVI signal with time. And actually from the crop and day layer, you can actually see what crop types they are. You can see in 2019, it was canola, 2020 winter wheat, spring barley, spring wheat. And then here's this cover crop year. So we put this cover crop, normally this would be fallow. The blue line is showing this low number. A low number means it's just dirt. So that's just fallow what we thought. The green line is that we started to grow and we terminated it. The orange is one that went till middle of July, and then we terminated. And the purple is we took it all the way to the end of July. And then this is the winter wheat following up this. And now we can see, okay, so the blue line was fallow. What did the winter wheat do? Oh, okay, the winter wheat jumped right up. Here's October, November of that following winter wheat year. Great, the fallow worked. And actually, the termination date one actually looks pretty good. The lines are on top of each other. Perfect. Actually see some sort of it's growing well, but unfortunately, the cover crops we took longer is actually affecting our winter. But you can see the growth, the fall growth was not as great. We take this all the way into the spring. The larger the number, so the higher this reaches, the better productivity you have. And you say, yeah, the winter wheat following fallow did better than the winter wheat following the cover crop, and you can just see it. Now these are NDVI units. This is not bushels per acre or anything, but this is actually a specific you, this is a productivity number. It's a relative difference. And if you had even went out and harvested by yield, you can actually kind of put some numbers to this. It's like, well, is that 5 to 10 bushels or what that is? You know, if you had the yield monitor, you can put on it. And then you can track this with time. It's as simple as dropping some pins down and making it work. So really it comes down to, try on-farm experiments. Come and make your trials long enough. And like say, if you want to use sentinel imagery, make it at least 60 foot wide. I would say put it your entire length of your field if you're comfortable doing it. Like if you're going to do some sort of amendment, or you actually would a nitrogen rate study, I'm going to drop my synthetics down by 15% or 50%, make them long. Include at least one baseline. Have part of your field that you don't do anything. If you don't have a baseline, you have nothing to compare to. So make sure you have something that was typically business as usual. I mean, consider taking a crop sample, or actually taking the soil sample efforts over in these trials and actually see, like, if you're doing nitrate, and so have more nitrogen available at the end. But you don't necessarily have to do that. Really, you can just look at some of this biomass. I'd encourage people to perform the same trial over multiple years to actually see, okay, so what if I did it and it happened to be a wetter year? And I would encourage you to put in the same trial in the same location. Sometimes reducing your synthetics nitrogen one year, everybody can get away with it because you're probably full of nitrate in your soil, but would it work the second time? And so doing over a crop rotational basis is what you could do. Real quick, if I still have time, I just want to show you the tool even. So this is Climate Engine. You can have a link. You can go in. There's a drop-down menu that you can pick remote sensing. Actually, you can get preset from this too. This tool has all sorts of things. But if you just do remote sensing, you drop down. It'll actually select from what satellite you want. You can actually do Landsat if you want. Those are higher, coarser resolution. But in this case, I'm just doing Sentinel. SR is surface reflectance. So I click on the Sentinel imagery. I want a mean over a certain period. And then you can drop down what time frame. Custom date, you can look at the last 15 days, last 60 days, last 90 days. I just do custom date range. In this case, I did June 15th to June 30th, and you can pick this up. So that's the image, and you can download this as a TIFF if you want. Just download the image if you want. To make the graphs I made, you can just click the make graph, and it just gives you points to put in. Here's a point. I'm going to add another point. Great, I want to put it here. I'm going to add another point and put it here. I can do polygons if I want. In the interest of time, I'm not. And then custom date range. Now I say, well, instead of just the month of June, heck, I want to go back to, I put this thing in 2022. I'll start June 1st of 2022. And heck, let's just take it all the way out to 2025. Let's see what's happened the cover crop trial was back in 2023. Let's see how these points are doing with time. Compute the time series. And depending on how long you take, let's take maybe a minute or two to go through this. But while this is processing, I'm happy to take questions or anything else. Yeah, there you go. So here's those 3 points with time. And if you say, oh, what graph? What was blue? Oh yeah, blue was that termination date 1. What was green? Okay, green was termination date 2. It's there. So you go back and forth. This is an interesting thing. And this is a common thing we found with cover crops. Winter wheat was bad. The cover crop, put the cover crop in the first year. The winter wheat actually, it takes a yield hit. So winter wheat following cover crop, we find, is oftentimes takes a yield hit. Guess what happened the next year? Look at that. The plots that had cover crop actually did better on a spring wheat. And oftentimes we see this in the second year following cover crop, we're seeing a benefit. So this delayed, I mean, this is a whole nother talk, is the organic matter that you put into your soil may becomes available later on in the second year following that. And remote sensing tracks it. Heck, I didn't even do a trial that year. I didn't even take the time. I'm just going to track it though, and or you can see what's going on. So, and you can go back in time. So anyway, maybe I've used up all my time, but any questions on that? Climate energy free. Just go in, make an account, jump in there. We actually have people here actually work with Climate Engine. Climate Engine was started by John Abotsoglu back at U of I. He was the kind of, he's now went to UC Merced. Now Climate Engine is run by Desert Mountain, or the DRI, Desert Research Institute in Nevada, along with UC Merced. But Catherine Hedgewick at University of Idaho, I go in here and I say, hey, could you actually do this? And they're changing things up. And so we have people, if you come in, you're like, oh, it'd be really cool to do this. And so you can customize this. There's an API you can grab to look at this. And so we're actually trying to put some custom tools together. Even for this cover crop project, we said, instead of having them go in and search, and what I didn't do is I didn't go, you show you how to like go in and search. I mean, essentially all I got to do is, zoom out. So what if the growers didn't have to go in and search their field? You can actually have a customized, so we can make a customized tool for individual growers. Heck, I would love to put soil tests in there. And then you have points that you can come back to this tool. So there's a lot. I mean, there's amazing amount of power in this tool. And here again, check out, you can do precip. You can make graphs of the mean L precip. Look at the last 6 days of precip, the last 2 months of precip. You just click on a point, they'll make the same graphs. So anyway, that's a whole nother talk if you want to get all the weather data. So we're a really cool tool as well. That. When do we do better on fallow? So it's all about water limitations. So water stress. So they do fallow just to store water in the soil, and that's the risk of doing a cover crop is you just don't replenish your soil profile. And really what we found was the cover crop by the spring, there was no difference in soil moisture. So actually over winter, it actually replenished itself. But it looked like it was the fall germination. So fallow you can find moisture, so the seed jumps off sooner in the fall. So really, that's what we're kind of looking at too. Is like, oh man, cover crops actually, if you terminate it soon enough, maybe you're not sucking them as much water. But it looked like a lot of times, if you don't get a wet fall, then that fallow is going to do better because that's more moisture available. So yeah, good question. So where do we download it? Good question. So here, and actually I want to go back to this because here's a download button here. This will download all these points as an XLS file. You want it as a spreadsheet? Heck, download it. And you can just pull it right up. And you can actually then have it for your, I just pulled it up. Yep, here it is. So there's the date. Here's every time the satellite went over. Here's the NDVI for, this thing staggers itself. But anyway, here's the NDVI for each of those points, and you can just pull it up. You got it as an Excel file. If you want to actually get the map, so you want to put it in your own GIS system because you like that, then essentially you can go and you can download as a PDF, or you can select a region, select a rectangular region, and I can just come in and I don't want to cover everything. Actually, maybe if I want my whole field, great. That's what I want to do. Give it a name, whatever, test, and download. And it'll just show up as a TIFF. And so you should be able to load that TIFF in any farm management software. It goes to the link, and it'll download it for you right to your computer. There it is, test zip file. Yeah, you're paying for NDVI. Yeah, absolutely. And this is one I think the land grant university, and here goes, let me preach a little bit, where I think the land grant university can come in and really work with you guys. We would love to come in. If you guys set up your trials like this and you have no problem setting up trials and all you want to do is have someone come in and help interpret, I mean, there is people like Courtney, like myself. There's people that know fertility or even know how to interpret things, that we would love to come alongside you at the end of a year. And you may have recognized my name from the IAMP, the Climate Smart Project, as the director. And in that project, which just if people want to know, it might still get going again. Looks like it might's going to start up again, where we can pay farmers to put practices in. And it maybe look like we can do a lot more regenerative practices, potentially, the way that the state secretary of ag maybe is now changing her stance that NRCS can pay for look like regenerative ag type practices. Then we could come in and put a baseline strip. We actually pay for the soil sampling. We'll pay for the crop analysis, and we can set up on-farm trials to convince you guys that are working or not. And I think Dan Strawn will probably share you with a little bit what we're doing up in on the up North Idaho on biochar. So
Awesome. That was so much great information. Thanks so much, Erin. Are there any last questions for Erin? And please feel free to absolutely you can unmute yourself and ask questions as well, or putting them in the chat is just fine too.
and just a heads up, I think I'll be at the Cropping Systems Conference in Kennewick in January, and so we'll have a computer here. If you wanted to come along and just try it, come. We'll have a table there. And I think with Courtney and Doug, I think what we're going to try to do is set up just a grower meetings, or maybe it's a virtual meeting. We'll have maybe sit down and make sure we do this. People are interested, and you guys can get behind the wheel, and we can come alongside and answer questions. So.
Yeah, I was gonna say that's a great idea, Erin. If folks are interested in this tool, maybe we can do like a case study. Yeah, either a workshop or a recorded workshop with someone's actual information and farm, and I think that would be cool. It seems like folks are interested. Well, we can work that out for later. Looks like Dan's raring to go.
Yeah, I'm just trying to make sure I'm able to share the right screen. You guys see this presentation?
Yes, all good. Thanks again, Erin.
Yeah, I was a little nervous about getting the screens. I have too many screens in front of me, so it's
It can get confusing.
yes. All right, so I'm Dan Strawn. I'm a professor of environmental soil chemistry here at the University of Idaho. I've been here for 26 years. I'm located in Moscow, Idaho. I have projects all throughout the state from southeast, southwest, northern Idaho, et cetera. I work on all kinds of systems, from agricultural systems to environmental contamination issues. I'm working a lot with dairy manure utilization. I would do water quality studies and water treatment studies. So I have anywhere there's research on environmental chemistry to be done, I have projects going in those areas, and I'm always interested in helping. So today, Courtney asked me to talk a little bit about some of the work I've been doing on biochar and using biochar to amend soils and improve the soil health. So that's one project I've been working on for the past years, many years. Okay. So I'll start out. What is biochar? Probably a lot of you have heard about it. It's really popular. There's a lot of interest in it. It's essentially, in its most common form, a plant material that you pyrolyze, which or burn in the absence of oxygen, and it produces essentially what we often think of as charcoal. You know, if you get at the end of a fire in your fireplace, if you have some charcoal material, that's essentially the same as biochar. Now it's much different than charcoal you would use in your barbecue. I mean, they're similar, but they're produced for different purposes. Biochar is really manufactured with the intent to use in a beneficial way in the environment, particularly soil amendment. And it really creates an opportunity to utilize this waste biomass to promote soil health and agricultural sustainability. So I'm going to go through that. Like I said, there's a lot of interest in that. It's especially the last 10 years or even more. It's really been popular. A lot of times we see fads that come and go, and they, 2 or 3 years, they run their cycle, but biochar really has shown to have some staying power, at least in terms of the interest and the potential to be utilized in soil as a beneficial amendment. It's in the scientific community, there's a lot of interest. Just in the last 5 years, there's been over 3,000 papers published on using biochar in soils. And you can purchase it in the store. So here's 3 products that are available in stores to purchase biochar for soil amendment. So why would you want to put biochar in soil? So what are the benefits? So there's many benefits, and so this schematic shows a lot of those. So one thing is it's pretty popular as a source of putting carbon in the soil to lock that carbon up. When you put biochar in soil, it will stay as biochar in that soil for over 100 years and even up to 1,000 years. And so it's a carbon sequestration, putting carbon in soils. It can improve the soil for drought tolerance, plant available, increases moisture retention, plant available water, improves nutrient retention, it improves microbial activity, it can improve soil health. And it even been shown to improve pest and disease resistance. Well, this all sounds great. So why shouldn't we just all be adding biochar to our soil to get all these great soil health benefits? Well, there's a lot of caveats, and I think that's what I'm going to talk to you about here in this presentation. What are some of the factors that you need to consider if you want to get the benefits of adding biochar to soils? And one is the properties of the biochar. It's a very heterogeneous material. You can imagine making biochar out of waste biomass or vegetation. It depends on what the feedstock is. What are you going to make that biochar out of? And then how are you going to make the biochar in terms of temperatures, available oxygen, timing, etc. It creates highly variable material. So 2 companies can be selling biochar and they could have completely different properties. And that's important because that's going to affect how the biochar reacts and affects the properties of the soil that you're amending it to. So essentially, all biochars are not created equal. And here's a table from a publication. I know it's a lot of data, a lot of information. It just really highlights the differences in the biochar. So here's these columns. Here's the feedstocks, everything from peanut shells, dairy manure, turkey litter, etc. And the production temperatures and the yield. And over here, I've highlighted some of these properties. Here's pH. Here's the surface area of the biochar. And here's another property that I'm going to point out is the ash content. That's essentially, if you burn the biochar, how much mineral matter is left after it's been burnt completely. And so if you look at the pH, the biochars, they're highly variable, and that's really important because it affects how it's going to behave in the soil. And it goes from 7.8 to a low to pH 11.2 to a high. So they're generally higher pH materials, but even then, it's a 3 or 4 pH unit difference. If you look at their surface area, which is really important because that affects how it interacts with water and nutrients. And so here we have one that's 448 square meters per gram, and down here's another one, 2 or 3 orders of magnitude lower, 0.9 square meters per gram. That's really a huge difference. And then finally, the ash content, that's that mineral matter, and it goes from 8.9 to 32.5% ash. So these biochars, where you get your biochar is important. And I'm going to dive a little bit deeper into these factors. And one of this paper was published in 2020, and it's a meta-analysis of 1,250 paired comparisons of biochar amendment versus non-amendment on plant productivity. Okay, so I'm going to show you a little bit of this data to show you how the different biochars affect plant productivity and how they affect soil properties. So here's the basic graph from the table. Now this looks really complicated, so I'm going to take a few minutes to walk you through it. The first thing is this graph shows the properties of the biochar. So just the same properties I went through in that previous table, how the different properties affect plant productivity. So here on this axis, we see the percent change of plant productivity. Okay, so let me go through that real quick. I've kind of blown up this axis here, percent change of plant productivity. With zero change, that means the biochar and the untreated soil, biochar treated soil and untreated soil, there was no difference. Okay, a minus 20 means there was less plant productivity, and a positive 20 means you got 20% more, and so on as you increase. Okay, so this is relative. This is plant productivity relative to the control treatment or no biochar amendment. Okay, so let's just take a look. The overall from these 1,254 paired control versus biochar amendment studies, on average, and these error bars are pretty small, so that's this value right here, it was a 16% increase in plant productivity. Okay, so based on biochar. Now, if we look at these biochar properties, here, let's take a look at this one right here. Okay, here, the pH, so the pH of the biochar was less than 7 on these samples, and you actually had a decrease in plant productivity, right? It's right around here, minus 10. Okay, so that's not a great biochar to use, as opposed to these biochars here that had a pH between 7 and 8. You got an average increase of about 20 to 25% increase in plant productivity. And then so on for these other pHs. Look at the cation exchange capacity of the biochars. Most of the cation exchange capacities is about, they were about average, but all positive. But this one, biochars that have a cation exchange capacity less than 10, they had up to a 40% increase. Okay, let's look at that mineral ash content. Okay, less than 10, 10 to 25, greater than 25% ash. Okay, as the ash content increases, you get more plant productivity. The total carbon for this one, if it has less than 30% total carbon, you get an 80% plant productivity increase on average. These other ones, it's more near the average of about 16. Okay, and the last one, the total organic carbon. If the total organic carbon here's less than 60% versus greater than 60%. Less than 60% was producing around 16%, 16 to 20% increase in plant productivity. Okay, if it's greater, you got very little effect, really. It's close to zero on average. So this is illustrating how these biochars are, their properties that differ. You get really vastly different effects on plant productivity. Let's look at the soil properties. How maybe some soils respond differently to biochar amendment versus other soils. Okay, so this graph shows that soil texture, soil pH, soil organic carbon, cation exchange capacity, total nitrogen, and the carbon to nitrogen ratio. Okay, the same axis here is the percent change in plant productivity versus a control. So if it's 0, means there was no change in plant productivity from the biochar amendment. So if we look at, soil texture, it really didn't have a big effect, a little bit, but mostly all the soils were getting on average 16% increase in plant productivity. Soil pH, when the soil pH was less than 6, you got the adding biochar had a really dramatic effect of increasing plant productivity up to 25 to 30%, say. Soil organic carbon, there doesn't appear to be a big effect. They're all near that average of 16% increase. The cation exchange capacity of soil, this had a really big effect. If soils that have low cation exchange capacity have a high benefit of biochar amendment. And soils that already have high cation exchange capacity, it's either no benefit or even actually on average, there's a negative benefit of adding biochar. to these in terms of plant productivity. And so on for total nitrogen. It does appear that soils that have a lot of nitrogen available, total nitrogen, do get a benefit from biochar, and the C/N ratio as well as reflecting that. So that shows you that. So in summary, for these two graphs, it's showing that the biochar type is important and the soil type. And I just want to make this one other note. I have this statement here, is that once you add biochar to the soil, it doesn't go away. It's going to be there for, I mean, on average, over 100 years. So it's not like fertilizer that gets utilized or pesticide that degrades. So you got to really think about what you're doing to the soil when you're adding the biochar. So how much biochar do you need to add? So this is a study we're doing up on Coeur d'Alene tribal lands, on a field where they were adding biochar. And we took delivery of this 334 tons of biochar. You can see these multiple piles here. It was a lot of trucks of biochar were driven here to deliver this biochar. And, there's a little shovel for scale. That's that shovel. So that's a lot of biochar. It had the dry equivalent of 150 tons. It was 11 semi-truck trailer loads delivered. On this site, they applied it to 50 acres at 3 tons per acre. Okay, so that's not really a lot of heavy biochar application. I'll show you in the next graph, really. And if you were to purchase it, it's highly variable. It's anywhere from $100 to $1,000 per ton. Plus, if it's a long delivery, you have to pay for that delivery, unless you can make the biochar on site, which has some benefits. So there's this, how much and the cost is an important consideration. I looked into the literature, published papers on application rates, and I made this histogram, and you can see it's all over. This is tons per hectare. So 0 to 3 tons per hectare, 3 to 6 tons per hectare. It's unclear. It's not a nice normal distribution. For a lot of the studies that we're setting up now, we're trying to do something around the 15 to 30 tons per hectare. On the Coeur d'Alene tribe side, we're down here at the 3 tons per hectare. And again, you saw how big those piles, how much biochar that took for that application rate. Okay, so there's another aspect, and I'm going to use this example of phosphorus recycling on biochar. So, right, we add phosphorus. We mine phosphorus, we add it to soils, we grow our crops, and then it ends up, in a lot of cases, going into the watershed and harming the water quality. We have there's technology to capture this waste phosphorus onto the biochar and reusing it by adding it into soils, right? And this statistic is really interesting. For 4 kilograms of mined phosphorus, it takes 4 kilograms of mined phosphorus to produce 1 kilogram of phosphorus in food. So that other 3 kilograms is being wasted. We could recycle it on biochar. Okay, but how exactly to do that is a question, and I'm not going to go into that in this presentation. Just real quick to show you some of the research that we're doing. We're taking this dairy lagoon, we're treating biochar with the dairy lagoon water, getting this biochar-based fertilizer. So now the biochar is not only has its original benefits, but we're also adding recycled fertilizer to it. And we did a test. We grew barley in a greenhouse trial. No phosphorus addition. Here we used conventional fertilizer. Here was a biochar without any no manure treated on the, and here's the dairy treated biochar. And you can see that the dairy treated biochar, the productivity was almost the same as the conventional fertilizer. As a matter of fact, they're not statistically different, but both were greater than the untreated biochar. So there is opportunity to make the biochar more valuable and get more bang for your buck by recycling nutrients. And this works for nitrogen too. Here's a paper from published on recycling nitrogen by utilizing biochar. I just summarize it here. It says dairy manure biochar can offset 23 to 82% of the nitrogen fertilizers needs of New York State. And this is a big deal. Synthetic nitrogen fertilizers are responsible for 2.1% of global greenhouse emissions And it's expensive. It's $400 a ton. If we could recycle it on biochar, you could offset some of those costs. So should you amend your soil with biochar to improve soil health? Well, biochar has a lot of benefits for soil health, but it depends on the biochar properties. It depends on the biochar source. It depends on the soil properties, and it depends on the soil health benefit goals. Short-term yield, sometimes maybe not, but longer term, there can be benefits, especially, you're adding soil organic matter to the soil. There could be water use benefits, and there are carbon storage benefits. You really have to evaluate the cost benefit ratio. It's highly variable. I always encourage people, I get calls, I want to add biochar to my whole field. I says, well, you might want to just carve off a small section and do a trial to see if you're really going to get the benefit to make it worth the cost. There are enhancements that can adjust the cost benefit ratio to make it favorable, such as nutrient upcycling to the biochar, and if you can get credits or payments, such as carbon storage. And there are really only a few studies out there that have looked at the long term, 5 to 10 to 15 years of the benefits. So sometimes you may not see a benefit in the first year or two, but for I would imagine in longer time periods, there could be effects and benefits. And so this is, a soil that's, perhaps an oxisol, a lot of low nutrient availability. And this is from historical in Amazon. They call this terra preta, where the native peoples of that region were putting charcoal in the soil and creating these dark soils that they call terra preta, and it really acted to influence the soil health and increase productivity. So you can buy biochar, like I said, it's out there, but you really got to consider what your goals are for utilizing that. So with that, I'll thank you for your interest in maintaining healthy soil for a healthy future, and take any questions if I have time.
Yeah, we have time. Thank you, Dan.
Sure.
Dan, I can start us off. So it sounds like one of the big messages is that sourcing is really important. How would someone go about finding a quality source, and like would you recommend testing that biochar? Kind of how would you go about that beginning process of finding a good source?
Yeah, that's a good question. I'm a big advocate is look at where it's coming from, because if one of the purposes of carbon is or biochar is to offset carbon emissions. And if you're ordering it and it's coming from a long ways away, there's a lot of transport carbon emissions that are going to be factored into that. If that's important to you, then just consider that. But if you just want to look into some of this to get it to promote some of the soil health benefits, again, look local, but there's a lot of producers, there's a lot of mom and pop type producers, and they can produce a good product. But again, it's going to be highly variable. I like, if I was to suggest someone to start, is go with a company that's more established. There are some out there, and that puts on their website the properties of the biochar that they've had measured from a soil testing lab.
Yeah, that makes sense.
Yeah.
Well, and I would think a lot of our audience is from southern Idaho, where we're a little bit farther from our forests. So thinking about a big application of organic matter, folks might lean more towards manure over biochar. I would assume dairy manure. But I love that you're combining the two and increasing the nutrient content with the biochar, with the dairy manure. That's really interesting.
Yeah, it is really interesting. We're doing quite a bit of research on that right now. We really think it's might tip the scales, so to speak, in favor uh, of using biochar to help the whole economic aspect. If you can replace some of that fertilizer, and it keeps the nutrients from running off into our watershed. Um, so, and you're right that in northern Idaho, we're near a lot of forest. As a matter of fact, the Forest Service has a whole initiative to produce biochar in forest from waste biomass from tree harvesting. But there's companies out there that produce biochar from cow manure as well. And there's one of the really interesting things I'm seeing a lot of lately is biochar compost combinations that seem to have a lot of benefits. So you might look into some of that if you're interested.
Dan, are you looking at the chat? Some folks have put some things in there.
Oh, okay.
Or I can read them off to you if you would like.
Are there any questions or?
Yeah. There's a couple comments. Great explanation about biochar caveats and variability. Erin Brooks has a comment saying, surprising that crop productivity took a hit with CEC less than 20, but clay soils, which likely have a CEC, or sorry, that was greater. Sorry, let me start over. Surprising that crop productivity.
I got that.
You see it? Okay.
Yeah. Yeah, I'm not going to dig too deep into the mechanisms. I appreciate Erin always pushing me here. Yeah, I'll look into that and see exactly what might be going on. But it is surprising, and that's the point. There is some soils could really benefit from biochar. Other soils, it's probably not going to hurt, but you may not get a lot of benefit. That's a main point. The stock material for the tribal biochar, that was a biochar produced from forest waste material. It came out of Oregon, and it was a federally supported biochar production producer, and so they got it for free. They only had to pay shipping, which it was still pretty expensive. I was just amazed to see these giant piles of biochar to amend for that 50 acres. And then how would it show up on the Haney test? Yeah, I have to look at that. I don't do a lot with the Haney test myself. I mean, I'm familiar with it. Yeah, that's a good question, and I'm sure I can find some papers out there that would maybe give us some insight into that. So if you're really curious and want to follow up on an email with me, I'll look into that. And then Lucille has given us a link to some biochar suppliers. So that's great. It's out there, and I think in general, like on average, it's 16% increase based on that meta-analysis. So there's a lot of potential for getting benefits and improving soil health, but it's a lot more. Unfortunately, there's a lot more complexities in the individual biochar and individual soil types in terms of how much benefit there will be. So anyways, well, we probably should finish up and let Mike get going on his. Thanks.
Oh, one more question if you want to answer that one in the chat, Dan.
Oh, I didn't see it. That was just a survey of research studies, and that's the thing. Nobody really, they all have justifications of why they selected different rates, but there's no test out there. There's no standardization. It's just what they feel like they should be adding or what they have available. We ended up at 3 tons per hectare at the Coeur d'Alene tribal site because that's all we could get. We wanted actually 10 to 15, but the shipping charges just limited us. And the supplier actually ran out. So.
Awesome. Well, thank you so much, Dan, for your presentation and answering the questions. Mike, if you're ready, we are ready for you. Once Dan stops sharing his screen.
Yeah. Stop sharing your screen, Dan. I think he left. You'll have to switch it up. But while we get that sorted, I'm giving you a hard time, Dan.
I'm trying to figure out how to stop sharing.
All right.
I don't see an option here to say.
Normally, I think it's at the top usually. If you kind of bump your mouse or your cursor up to the top, it should shoot down a box that says stop share. There you go.
Perfect.
This is the first time Dan's used Zoom, so give him a little grace.
And I will. All right. Are you all seeing that, or are you seeing the other one?
No, it looks good.
Okay, perfect. All right, so brief introduction. I'm Mike Strickland. I'm also with Department of Soil and Water Systems, along with Dan and Erin. We have a variety of different projects that we work on. A lot of my focus tends to be, though, around kind of soil microbial communities and how those communities can impact or interact with management regimes or other factors to impact things like soil carbon storage or nutrient cycling within ecosystems. I'm also currently the director of the Deep Soil Ecotron facility that's being built on the University of Idaho campus. And I promise that'll be the last time I mention that during this talk today. But what I want to talk to you all about this afternoon is really this project that that is currently in year 4. It's a USDA funded project to look at these sort of like responses of multiple management strategies and their kind of interactions, right? So trying to understand how, let's say, different cover crop regimes interact with composting or intercropping or even grazing to some degree, and whether or not you're getting some sort of added benefit from implementing more than just one sort of management strategy at the same time. And this kind of comes from, obviously this idea of soil health, and that if you're increasing plant diversity, could you potentially increase or, can it lead to increased plant productivity? Does it lead to this increase in soil function? And if you increase diversity, do you get an increase in overall kind of ecosystem function or your system's function itself? And really, a lot of this was kind of pushing on this tenet of maximizing diversity within from the kind of principles of soil health. And I'm not saying that we don't also potentially maximize living roots and some of these other things with these, but really what we were trying to do is manipulate diversity in a variety of different ways. And so the schematic of this kind of project is that we had this gradient of cover crop regime. So we were going from 0 cover crops all the way to 12 species of cover crops. And then we were doing things like we were adding compost to treatments, right? Adding compost to treatments, or we were simulating, and we had to simulate grazing because of the location we are. So there's a lot of caveats associated with that. But it was essentially mowing and removing 50% of the cover crop biomass. We also, though, had during the growing season where we are implementing either intercropping or no intercropping in the cash crop. So this wound up being a relatively complex experiment. And I can also highlight some of the difficulties that we've had just trying to get everything to work all together, which is sometimes kind of fun. Including, for instance, in the first year, failure of cover crops because we didn't have enough rain, or we got them in too late. Or then the second year when we tried to implement cover cropping, and then we had a swarm of starlings come through and basically eat all of our seeds that were just planted. So it's also been interesting in trying to integrate this into a system that is typically not, always integrating a cover crop into the system. So this is done over in the Pullman Plant Materials Center, USDA Plant Materials Center over here near Pullman. And so typically, they're running almost a continuous rotation of either winter wheat or some pulses within this cropping system. But ultimately, we were able to start to get some of these treatments to actually work. And what I thought I'd do is show you a few of the results from that project. So in this year, right, what we were able to do is if you look at cover crop richness, what we have are our 0 species to 12 species. What you see is that above ground biomass, and this is cover crop biomass, tends to increase with increasing species diversity. ultimately, you kind of get this attenuation, right? Somewhere around 6 species. So you're not getting a huge increase in biomass between 6 and 12, but you're definitely getting an increase where you don't have any cover crops to where you do have a cover crop, and even above that. I'd also like to note, though, that when you have a single species, sometimes you can have a lot of variability, and that's because in some instances we have different cover crops, right, that we're looking at. So this is a randomized selection of individual cover crop species. So in some instances, you might have something like vetch, which puts out a lot of biomass. And so you're kind of getting that variability associated with that here too. Now we look at below ground biomass, right? We also get a very similar sort of result from 0 to 12 species. Again, low below ground biomass with no species of cover crops, and then we get some bump with a single species. And then we kind of hit 6 and 12 species where we have some of the highest below ground biomass in these systems. And you'll also note, right, at the 0 species, that just means we had weeds in those fallow plots. And so we're accounting for essentially what's weed biomass within those within that 0 species cover crop mix. The other thing, though, that I think is interesting here is that if we start to look at cover crop biomass, right? So again, this is tracking from 0 to 12 species, as you can see here. What we do see is that there tends to be a relationship between how much cover crop biomass we have in that system and how much POC we're detecting within that system as well, which is indicative of like what Erin was saying earlier, where you're getting these cover crops in that system and you might have this potential to start to build soil organic matter, right? So POC can be this early indicator of bioavailable carbon going into these systems, which is kind of interesting, I think. But what we're also noting, though, and I told you all about all those treatments that we put into place. If we're looking at this below ground biomass again, what we start to see is that there's multiple interactions between cover crop diversity and these other treatments that we're implementing within these systems. So for instance, if we're adding compost, right, what we're tending to get is like actually a bump in below ground biomass where we have no compost versus where we do have compost. In particular, at these 12 species, 12 and 6 species treatments. And that is that they're just not allocating as many resources to below ground biomass where you have compost because they don't need to, because those nutrients are available for those cover crops in that system. And so they're going to allocate fewer resources to roots. However, when we look at like something like mowing, for instance, we actually see that below ground biomass, excuse me, tends to decrease, in particular where we have higher diversity of cover crops when we mowed, right? So the light blue is where we mowed versus the dark blue is where we did not mow, right? And so what we tend to see is you almost get this kind of effect where you're getting the highest below ground biomass in the 6 species with this mowing in comparison to the 12 species. And we also see something along something with if the previous season was intercropped, what we also tend to see is that we get a strong kind of increase in below ground biomass in these cover crop species with intercropping. But if we have a monocrop, right, so we just planted barley alone in these systems, we actually see that it drops off where we have the 12 species mix in this instance. And so I think there's some interesting interactions going on here, and we're starting to kind of try to disentangle some of these. And as I mentioned before, I really do enjoy microbial communities, so I'm going to present some of the microbial community data now. I always hate this because, it's really hard to represent microbial communities and super high levels of diversity within these communities. But the real take home from this is that what we see is that the real driver of bacterial community composition winds up being composting in these systems. So what we see is that we get different communities where we have compost added within these systems versus where we don't. And that even though we tend to see some spread or some differentiation with cover crop diversity is having a much weaker effect overall on these below ground communities. Now, this is just like kind of like who's there, essentially, right? What organisms are we finding within these communities? What one of my graduate students, Cameron Richardson's been doing is looking at network analyses within these, right? And so this is kind of measuring the connectivity between the different organisms within these systems. And in fact, what you can kind of get at is whether or not these communities are indicative of more competitive communities, so they're kind of fighting against one another, or they're more cooperative sorts of communities. And it's the idea that they're sharing more linkages across the entire community of organisms that we're observing here. Now, the big takeaway from this, and this data can be kind of tricky to represent, but is that what we tend to find is that where we have 6 species mixes, we actually tend to get more cooperative sorts of indicators within these networks. And in fact, you can kind of see that some of this is driven here. You can see that in this 6 species treatment with composting and actually with grazing versus this 1 species cover crop community with composting and without grazing, you start to see that you get like more of these nodes, these circles that have connections shared amongst them, right? Versus this 1 species treatment where you have a few nodes shared, but you have a lot of individual or these nodes that are just kind of out here without strong connections to other nodes. And so what that means is that potentially these communities are more strongly linked to one another than these communities here, which could be indicative of whether or not these communities are more or less resistant to future stressors in these systems. And I think can be something that we're actually looking to follow up on and seeing how it relates to some of these other soil health indicators that we might be observing within these systems. Now, as Erin mentioned also earlier, right, and this may not be too surprising, when we look at barley yield following these cover crop treatments or these whole slew of treatments, what we tend to see is that yield tends to decrease where we have cover crops. And in fact, it doesn't seem, that yield decrease just seems to really be strongly linked, at least in this system, to whether or not you have a cover crop in place or you don't, right? So you tend to have greater yield following these treatments in the fallow treatment versus where we've added these cover crops. But we also having all these other treatments in place, I think something that was kind of interesting that came out of this is that we start to see these other interactions coming into play. Let me see if I can get I'm chasing my cursor on multiple screens. Sorry, everyone. What we start to see, though, is that we get this interesting interaction, though, between intercropping during the cash crop season where we're planting a pea with this barley and composting. And so the thing is that if you're adding compost to these systems, we see no difference in yield between intercropping and monocropping within that system, right? So compost can help to potentially, or an addition of compost in this instance, could help to potentially offset some of those losses that we're observing with the cover crop. But we also see, though, that where we're intercropping and we're not adding compost, we see that intercropping gives you a bump in yield as well, compared to where you didn't intercrop, right? So that monocrop without compost. And so, roughly equivalent to what you're seeing with composting in this system as well. And so I think there's a lot of these interesting kinds of things where, adding more and more treatments on top aren't necessarily always going to give you a greater overall outcome, but they might help offset some of these declines that you might see while you're waiting for, say, cover crops to build soil organic matter within a system, for instance. The other thing that we're kind of starting to see from this, and this is kind of something I wanted to really highlight here, is that, different management strategies tend to have these different outcomes. We're not always seeing really strong interactions. And I didn't present all the data that we have. We have a lot of data on this, but what we do see is that sometimes you're seeing that, cover crops matter for this particular soil indicator, like microbial biomass. But, intercropping can matter for yield, for instance, or it can matter for pH or something else like that, right? So these different management strategies aren't always adding up to a stronger effect on any one particular variable. But you are seeing that as you're adding them in there, you're getting these different effects. And I think that's interesting because it indicates that more management strategies may not necessarily lead to overall better outcomes, but you might be able to implement management strategies that will deal with a specific issue that you have or that you want to improve upon within a system. And I think right now we're kind of stuck with this idea that throw everything at it is what you're going to, and you're going to get something better from that. But I don't think that that's necessarily the case, at least from what we're seeing. And that the idea is that if you want to target something specifically, then you could target something specifically and hopefully improve that. And with that, I just have this this kind of acknowledgement slide. I want to say, obviously, thanks to all you for being here and sticking around and joining us late today. This project in particular was funded by USDA. And then acknowledgments to Cameron, Connor, Vanessa, and Jess, who are all students and postdocs working on this project. Zach Kaler, who's a co-PI on this project, and Stephen Lee, who's over at the USDA Plant Materials Center in Pullman, Washington, who has been really basically helping us out, implementing all these treatments, and helping us to manage these, and giving us basically the field location to do this work. So thanks, everyone. I'm happy to answer any questions you might have.
Oh, Mike, I feel like you just said that there's no easy solutions.
Well, you hate that, don't you? I think there is, right? I mean, I don't think that there is an easy solution, but I think there are solutions that help you manage particular components of your system that you want to manage. And I think that sometimes we've been promoting this idea that you do all these things like plant a cover crop, right? Do no-till, do all of these things. And you're expecting to get like, you know, this awesome outcome, right? But as we know, there's never a silver bullet for these things. And and it may help if we start to think about how can we be more selective in our management strategies to get a specific outcome that we want to get at.
Yeah, for sure.
And I'd also say something that we found too in other studies on cover crops, right, Courtney, is that, you know, we're promoting like plant a whole diversity of cover crops, but sometimes what we see, right, is that you actually can get lower yield of those cover crops, not yield in your cash crop, but overall lower biomass production in some of those. And sometimes if you're planting a specific, less diverse suite of cover crops, you can actually get higher yield in those and stronger outcomes. And so I think there's a lot of questions about how we actually manage those things. Sorry. I'm happy to go off on tangents, but it looks like Sean has his hand raised. Sean, do you have a question?
Yeah, Mike, I was curious about the fields that you were doing that study in. That is
Yep.
dryland farming. Okay, and so was
Yep.
Erin's, and I think in both cases it was mentioned a drop off in yield following cover crops, and in both cases, would you say that that was largely due to water availability?
You know, in some instances, this could. I mean, we were trying to, when we could get these cover crops to work, that's the other thing that I would say, particularly in this system that can be really tricky, right? Is getting those cover crops in to where they're going to get enough fall precipitation to actually, it's nice that they actually start to germinate before winter and they get some roots going, right? And they emerge. And then they overwinter, and then you get some spring rains to where you can actually get some positive growth. Because what we were trying to do, and I'll admit this, in the first year, we were, you know, because we can do this and because we're looking at like trying to get these cover crop effects in this system, we pushed that too far in the spring because we were trying to get really good cover crop growth and we weren't getting it. And then we missed our window to plant our cash crop, right? And so then we had a cash crop failure, and that sucked for us anyway. And I agree. Like, I think that is what's tricky, but where we've had really good success is getting that in at the end where you have enough rain to get germination prior to winter, and then terminating them before you're out of that window of precipitation in the spring. And then we tend to have good cash crop germination, Sean. It is a tight window though. And sometimes you could be planting, I feel like you could be planting cover crops here and you're getting like potentially no biomass yield from them and potentially no biomass benefit from them, which sounds not so positive. But I
I'm
think you dealt
curious.
with similar things, right, Aaron?
Well, I guess I would say yes. There is that the fall, germination period, and when you actually get some growth. But we did see Sean in that year with Kendall Call. She had experiments that we saw actually one year actually the cover crop, the winter wheat fallen cover crop was doing well. Goes into about April, end of April, then you see the yellowing. You see this, which to me, the moisture is pretty similar, and it was more of a carbon nitrogen ratio type of thing. I think we just sucked a lot of the nitrate out, and that just stunted it for a while, and it never caught up. And so I think there is that the carbon nitrogen within the previous cover crop. What we actually starting to recommend is, if you put the cover crop before a year before your winter wheat, then we don't see any hit. So put it before your legume or put it in it. So where you put your cover crop, we did have a year, I think it was last year, we actually didn't see any yield hit with the winter wheat and actually saw some benefit even in the first year. So I mean, here go on to this year dependent, but yeah. So it could be nitrogen, but overwhelmingly water. Yeah.
And
one thing that's a little bit frustrating to me is that there is so much focus on cover crops in the soil health world. And, that's just when you're talking about diversity, that's one of the tenets of soil health. Focusing on others, minimizing disturbance, keeping it covered, keeping a live root in the ground. There are other things to concentrate on, I think, that may well be as important, if not more important. And perhaps in an environment of dryland farming, focus on the other ones could be really useful too. And I'm not sure what those studies would look like, but it just seems like cover crops just get hammered on in the soil health world so much, because that's what people seem to equate with soil health in a lot of ways. And it's just really frustrating from my point of view, because it seems like we're missing the boat with the other tenets, the other principles of soil health.
well, and I would also say, Sean, like I think that it's that idea too that you're doing these cover crops and you're like pushing diversity in those too, right? And sometimes I think that what we've observed, at least in these systems, is that I think what matters a lot is what can you get in there that is going to produce a lot of biomass in a short period of time seems to be one of the more beneficial things. And that's not always a high diverse mix of cover crops, right? It could be we actually had a summer cover crop experiment that we did here too, which was actually pretty fun because we were able to grow things like sunflowers and stuff like that. But what you see is that you get those sunflowers in that system and they produce a lot of biomass and they produce a lot of shade over to that ground, basically that ground cover. And we're actually seeing that we're getting an increase in soil moisture in those in those sunflower treatments over the summer compared to the fallow treatment. And you're getting a lot of biomass, and we're seeing a positive subsequent wheat yield in those systems. So I think that there's instances where planting diverse cover crops maybe isn't the answer. And this is one of those systems probably too. And I agree with you too. Like I think that, this was part of this was trying to figure out, here we have cover crops, but how do we implement these other treatments on top of this that might be considered kind of cover crop? And I know grazing or mowing fits within cover crops too, but you know what I mean? Like if we're composting or if we're intercropping in the cash crop, how is that helping us to do these things as well? And in some instances, they work better than cover crops, right? So
and I appreciate the fact that the level of complexity when introducing multiple things like you have it goes up considerably. It's not. I don't think that was an easy. I don't think that was an easy study to do at all. My comments are more general. I really appreciate what you guys have presented today.
Yeah, cool. Oh, let's see here. Looks like Barry has a question here.
Yeah, Barry doesn't have any audio though, so you'll have to try to type the text.
Okay, I'll try to answer and read. I'll read first and then digest, and then I'll try to answer. I have fall planted winter forage, type triticale, barley, and wheat, all beardless, along with Italian ryegrass and kale collards and rape for spring May grazing to lamb on pasture. Soil is pH 8 SOM is 4 plus, but calcium base saturation rate often below normal range. Your thoughts? This is where I need a soil chemist. I need Dan on here.
Where's Dan?
I'm trying to think of like why that would be lower. Do you have any ideas, Erin? I was trying to think of what we were observing for some of our, because we were looking at some, that was plant calcium. Sorry, I'm just looking to see if we had other things that were going on too. And I'm just not sure that I have a good answer, that I feel like I'm the best person to answer that question.
And that's okay. This has
Okay.
been a question that Barry's had for a while, and I'm sure if anything you could give him, he would be happy.
Yeah, it might be something I need to look at and think about some too, if that sounds fair. And maybe I can shoot you a response too, Courtney.
Yeah, yeah, I can connect
Okay.
everybody and we can try to tackle this for
Cool.
you, Barry. Perfect. I'll just copy this down real quick.
So, Mike, maybe you can confirm at least what I've found in our cover crop projects is one consistent thing with increasing diversity. There's at least increasing diversity or potentially even abundance of biology. Above ground insects, below ground arthropods. You're seeing the same thing. Do you ever see that, you know, there is, some hit by somehow that seems to be a correlation I've noticed, but maybe I haven't seen all the experiments.
Yeah, and I think it does tend to do that. I just wonder, we also tend to see that increase, right? I mean, we push this with the 12 species mixes as well, right? Because what we've done in the past was like a 6 species mix in the summer. But also sometimes we see that those intermediate levels, right? Like what you're doing is you're getting that diversity effect starts to asymptote, right? And you start to see that like it'd be nice to know where that is. And I don't know that it's always the same, right? It's going to depend on what your system is. And it's not saying, yeah, it's like there's so many different things that you can measure too, right? That like I remember like the summer cover crop stuff that we did. We went out there and it was like alive with pollinators because we had all these different, you know, flowering cover crops in there, and it was just crazy. And you could see obviously in a single species treatment that was a grass, you have no pollinators, right? But in some of these others, you have like, you've got beetles and bees and flies and all this other stuff all over the place, and it's just kind of crazy. Um, and that obviously has a really strong effect. And I think that, you're getting that kind of succession of when these plants are flowering, because they're not all flowering at the same time. And so like these pollinators have really, something to move from one after the other. And I think that that's key. But then sometimes like if we were looking at like the soil characteristics, like I'd almost always plant like a sunflower legume mix in there and call it good, at least for that treatment. Um, but then there are these other instances where I think, I sometimes think that where we're hitting the issue is where we have these higher diversity mixes that sometimes you have a lot of what are really pretty similar species in there, you know, and they're competing with one another then. And so they're not like complementing one another as well. And I think sometimes that happens too when we start to layer on a whole bunch of organisms that, highly diverse communities of these cover crops, because we're also selecting those for particular traits, but we're limited in how different they actually are from one another, right? I
Yeah, I
eh,
mean, I guess that I agree that I'm saying that the diversity causes more diversity in
mm,
the cover crop causes diversity and actually abundance of more of the different biology. But I
yep.
just finished a 3-year project that their diversity had no impact on yield. So
Right. And
the middle to the high. So if you want crop performance rated as yield, it doesn't seem to make impact. But if you actually see what's happening, there's something happening. Maybe in the long run, maybe it'll make a benefit, or maybe that's
right. Well, and we don't have this study is still it's in review right now. Again, it was this 0 to 6 species summer cover crop mix, but then we had this fall it was that drought we had a few years ago, right? Where basically no cover crop germinated. It was just, basically it wound up being cover crop, then fallow, and then we planted winter wheat. And then we see this strong winter wheat yield effect where we have these cover, you know what I mean?
Yeah,
And it's almost I don't know if you're just constantly putting that cover crop in there that you're yielding always that bit, or does it need a break too? I don't know. There's lots of questions there, I think, that are kind of interesting.
Yeah.
And then there's another component of this, and I didn't really talk about this too much, but one of the master students who just finished up, Connor, went out and found paired sites that were kind of doing more soil health management strategies versus fewer. And then we brought these soils back to the lab. And then he implemented these various treatments of either increasing soil temperature or decreasing moisture, or the combination of these. And what you do see is that those folks who are implementing these more maybe regenerative agricultural practices, those soils tend to, everything gets hit, right? It doesn't matter if it's conventional or regenerative. When it gets hit with drought or higher temperature, you get the same response, right? Or the same magnitude of response. But what we do see is that they recover faster if you've been managing them from a regenerative standpoint, at least in the lab. And I think that's something that's kind of interesting too. So I think there are those sorts of benefits too,
Yeah.
It's just that, if there's no water in the system, it doesn't matter who you are, it's going to suck that time. But then as soon as water comes back, you might actually be able to take advantage of that faster.
Yeah.
And by you, I mean, your soil. So anyway, cool.
That resiliency component, I'm glad to know that's we got that.
Well, and resiliency is hard to measure, right? Actually, and it can be hard to measure in a quantitative way that we can put a number on all the time. So
for sure. But if we're seeing a better or an easier transition or a bounce back from a drought year or whatnot, then that's a nice indicator. Okay. Are there any other questions, comments? It looks like all of our speakers are still on. If we have any last minute questions.
Well, just maybe to comment to Sean too about other things that people are doing that are showing some indication of improvement. And I think Mike showed this too, was adding compost. We have growers now hauling compost in from up to 100 miles away and showing yield boosts. So there's other things you could go on. Compost may be one of them that, particularly it looks like maybe even the biology that they're importing in. It looks like them out there, they're actually laying on as a nitrogen source. Is actually some other things are going on that helping that. So just a comment, an observation, and that's another maybe 5 for 5 talk, but there's some testimonials out there about that.
I think that's a huge subject. How do you get more carbon into the system? I mean, ideally, you get it through plant roots that are, pulling carbon out of the sky and fixing it through photosynthesis and leaking it out through the roots and so on. But if you can haul it on, maybe that's the jump start. Maybe that's the jump start you need. And Dan's presentation is talking about the biochar and on average 16-20% boost, and that's pretty impressive. That soil carbon amendment practice of ours, we covers biochar, and it has to be tested and compared to with 4 different nutrients and so on.
Well, and I
thought I might mention that earlier.
Yeah, I've been pretty impressed by some of the work that's coming out testing compost biochar mixtures. And it's not new. It's been done for the last 5 or more years, but it's showing to be really a high value mixture. So keep your eye on that.
That seemed to make good sense to me too, especially when you consider some of those materials have that super high specific surface area. They're going to want to grab onto things basically to make it simple
Yeah.
conceptually, right? And so why wouldn't you combine them with something prior to application, just to
Yeah.
kind of hedge your bets into how that soil is going to react to it.
Yeah.
Yeah.
And
Yes,
I think too, like I don't have the rate right in front of me of what we were applying, but it's not like a huge amount either. It's just kind of enough to start stimulating that system to some degree. Which I think is, we go out there and put it on there and you're like, did we put compost on here? Because
well,
but
that's
it
what
definitely is having an effect, right? And some of the things that we measured for sure. So
that's why I thought the grower that I was working with, he only put 1 to 2 tons per acre of compost on, which is just there's nothing in it really. But it was enough to stimulate it, enough carbon maybe to activate things. And yeah, that's interesting. I did have it was interesting last week we had a grower meeting and I was showing off this climate engine tool and I had some guy come up to me and he had put on I was showing it and I had shown the plots like, I actually put on some biosolids. He's getting the Bartech stuff shipped from Western Washington and he's laying it on his field. I put it on this part of my field up on that clay knob. Could you see a difference? And we just zoomed in, clicked on 2 different points, complete showed the inverse. So the crop productivity was the lowest product, and now it's the highest productive field. And yeah, obviously the bio amendments, anything you put on is going to make an improvement. Of course, now he's getting hit with all the regulations of PFAS and everything else that's in those biosolids, but another problem. But certainly a way that, we know that sort of addition would work if you can make it. And I guess to follow up on what Dan was talking about, biochar, Dev Shestra, I think he has plans to actually go to sawmills and actually figure out, it does have a way to convert, some of the burning they do of the byproducts into biochar. And, if we think, the supply of biochar is our biggest limitation, Idaho has a lot of sawmills and we could actually make a lot of biochar if that engineering kind of comes together. And I think he's trying to look for ideas of how to make more of that and make it more available.
Awesome. Great. Well, I appreciate all of the additional information there at the end.
Sure.
I think it's very helpful for people. Okay, well, let's call it, and everybody can go to lunch. I really appreciate all of our speakers being here. Thanks so much. We'll have so much to learn from you, clearly.
Yeah.
We have 2 more 5 for 5s going on. Our next one will be on January 28th, and then we have another one on February 25th. And those will be actually one of the topics is on human health and how it relates to soil health. And I'm spacing on the third topic, but yeah, thanks
Soil
again,
health
everybody.
tools.
Say it again.
Soil health tools.
Oh yeah, soil health
Yeah, in
tools, all
January.
the cover crop tools that are out there that are available to help people select cover crops and a couple other ones as well. So but yeah, okay, well, thank you so much
Thank you,
everyone
Courtney.
for sticking around with us and dealing with the delays this morning. Thanks to our speakers, and we'll see you all next time.
All right. Good day.
Thanks, Courtney.
Thanks, Courtney.
Thanks, everyone.
Yeah. Bye everyone.